My name is Steve, and I'm a graduate student at Colorado State University in the Department of Mathematics. In today's lesson, we'll talk about the role of mathematics in science and engineering and how mathematical models are used to predict and understand nature. Modern research uses the scientific method to answer questions about nature. At the heart of the scientific method is the process of stating a hypothesis, gathering data, and analyzing the data to see if it supports the hypothesis. To do this analysis, we need a set of tools that we can use to make statements about collections of data that other scientists can rely on. This is where mathematics comes in. It gives us the tools to analyze data and a clear and concise language we can use to communicate our results to others. Let's look at some examples. Very often, the type of question science tries to answer is what effect changing one thing has on something else. Does adding carbon dioxide to the atmosphere increase global temperature? Does adding antibiotics to cattle feed increase the number of bacteria that are resistant to those antibiotics? Does reducing fat in your diet decrease your risk of heart disease? Does increased time watching television lower a person's IQ? Does caffeine increase or decrease performance on exams? For these kinds of questions, we use the mathematical tools from statistics. We call the input variable a treatment and the output variable an effect, and collect data by measuring the effect for as many different subjects and treatments as possible. Then statistical analysis can tell us whether the effect is really caused by the treatment and with what level of confidence we can say this. It also tells us how many data points we need to gather if we want a certain level of confidence in our result. Another type of question that commonly comes up in science is how to predict how some system will behave under certain conditions. For example, at what temperature would a microprocessor overheat and stop working? What happens to a bridge under a high wind? How should we change the shape of a car to minimize wind drag? How does the height and blade length change the amount of power that a wind turbine can generate? How do chemical signals influence the way cells organize themselves during development? In these cases, mathematicians create a mathematical model of the system and then use the model to predict behavior. A mathematical model has a set of inputs such as temperature, wind speed, the shape of a car, the height of a wind turbine, and to generate a set of predicted outcomes or behaviors. Often these models have a number of parameters so that we can apply them to different situations without having to develop a whole new model. Some of these mathematical models are fairly simple, like Newton's second law of motion, that says acceleration is force divided by mass, or his law of gravity, which is force is the universal gravitational constant g times the product of the masses divided by their separation squared. These are simple enough to write down a single equation and then solve it. But most models aren't this easy. Very few real-world equations can actually be solved, and some systems require models that have many complex equations. So mathematicians usually have to resort to computers to simulate how these models behave. As computers become more and more powerful, mathematicians can tackle more and more complex models, like global weather, complex biological systems, aerodynamical systems, financial markets, and the engineering of nanoscale devices. Now you can try some mathematical modeling yourself. I've created a computer simulation of diseases and how they spread through a population. The simulation lets you control the number of people, what percentage of them have been immunized to a disease, what percentage of the people have the disease to start out with, and then it lets the disease run its course and counts up the total number of people that got sick. Your assignment will be to use this simulation to gather some data, build mathematical models of your data, and use your models to make predictions, and then test your predictions using the simulation again. Good luck.